Hello everyone, once again, this is Sir O, your teacher in this session. And by the way po, kung first time nyo po dito sa aking classroom, pwede nyo pong bisitahin ang aking YouTube channel na Sir O at pwede nyong mapuntahan ang ating video section upang makita nyo po ang lahat ng mga video tutorial ko pong nagawa lalong-lalo na para makatulong po sa inyong pag-aaral. At huwag nyo na rin pong kalimutan mag-subscribe sa aking channel. Free po ang pag-subscribe, wala pong bayad. I will really appreciate po kasi malaking tulong po yun sa akin. Kalimbangin nyo na din po yung ating notification bell. Click all para po ma-update kayo sa mga susunod ko pang mga tutorial. What we are going to talk in this session is we are going to illustrate what is factor theorem. So let us start. So before I will show to you what is the definition of factor theorem and its converse, let us first recall our remainder theorem. So in our remainder theorem, if we have a polynomial function in x divided by x minus c and we are looking for the remainder, we know that in the remainder theorem, it is only equal to f of c. This c is actually the value of x that we are going to evaluate the polynomial function by substituting the value of c to our x in the polynomial function. Take for example, we have x squared plus x minus 6. So let us start or let us recall very simple example. X squared plus x minus 6 divided by x plus 3. So if we are looking for the remainder, there are two ways that we are going to do. Either the long division method or the synthetic division. So in this session, we will be using the synthetic division. Now, in synthetic division, as we all know, our task here is to get all the coefficient of the given polynomial function. So, in our quadratic term, x squared, the coefficient is 1. In our linear term, the coefficient is also 1. And we copy the constant, which is negative 6. And after this, we will be looking for our divisor. By looking at x plus 3, we will equate that one to 0. And applying addition property of equality, our x is negative 3. So our divisor in our synthetic division is negative 3. Now our next task is we are going to bring down 1. After this, we will multiply negative 3 and positive 1, and we will write our answer below 1, and that is negative 3. After that, we will add 1 plus negative 3, and that is, of course, negative 2. And let's go back with the first step. We will multiply again negative 3 and negative 2, and we will place it below negative 6 for our answer. So the product of negative 3 times negative 2 is positive 6, and negative 6 plus 6 is, of course, 0. Therefore, our quotient in this given polynomial function divided by x plus 3 is actually x minus 2. And oops, our remainder is 0. So once the remainder is 0, it means that x plus 3 is a factor of x squared plus x minus 6. That would lead us to the definition of factor theorem, which states if f of c is our remainder, isn't it? With our remainder theorem is equal to 0, then x minus c, this one, is actually a factor of f of x, which is the given polynomial function. So this means that if our f of c, which is the remainder, either the synthetic division or the long division method, is equal to 0, automatically x minus c is a factor of the given polynomial function of x. So in other words, if in our example x squared plus x minus 6, since the remainder is 0, x plus 3 is one of the factor of the given polynomial function. But here in this case, x minus 2 as our quotient will be our second factor. So there are two factors of x squared plus x minus 6 because in the given polynomial function, quadratic function in nature. So there are two factors for this given polynomial function of x. So I hope you really understand because if you can divide this polynomial function equally by x plus 3 and x minus 2, that would mean that our factor x plus 3 as the given by converse, if x minus c is a factor of f of x, then f of c should be 0. So this means if x minus c is a factor, then we know that f of c or the remainder should be 0. If you have some question, I will really be happy to answer them. Just write it in the comment section. So this time we will have, shall we say, a tiny game. I would like to welcome you all in our very short game entitled Is It a Factor? I'm your host today, Sir O. So what we are going to do here is that example we have a polynomial function and a potential factor. Why it's potential? Because we are going to give a proof that x plus 2 would be a factor or not a factor of the given polynomial function. So what we're going to do here is we are going to equate x plus 2 to 0. And after that, applying addition property of equality, x is equal to negative 2. And what we are going to do with this x is equal to negative 2 is we will replace all x in this polynomial function. So let us start with x cubed, replacing it by negative 2. So we have negative 2 raised to the power of 3. So if you notice, we just replace x by negative 2. Next is we will replace x in x squared. We have 6 times negative 2 raised to the power of 2. And we will also replace x in 11x. So we have 11 times negative 2. And we copy positive 5. And after this, we will simplify further. And we know that negative 2 raised to the power of 3 is negative 8 because negative 2 times negative 2 is equal to positive 4 multiplied by negative 2 is negative 8. And we know that negative 2 raised to the power of 2 is, of course, that is 4. So we have 6 times 4. And 11 times negative 2 is, of course, negative 22. And we copy again positive 5. We will simplify this further. So we have negative 8 plus 24 because 6 times 4 is 24. We just copied negative 22 and positive 5. So if you notice, I already highlighted rather our terms that are of similar sign. So we have negative 8 and negative 22. Of course, that is negative 30. And 24 plus 5, that is 29. And negative 30 plus 29, they are unlike signs. So therefore, we will subtract them. So we have negative 1. Oops, negative 1. Negative 1 is not equal to 0. And since is not equal to 0, therefore we can say that x plus 2 is not a factor of the given polynomial function. So if you have some questions, I will be happy to answer them. Just write it in the comment section. We have another example. Let's say x cubed minus 4x squared minus 2x plus 5. And we have a potential factor. Now, if you notice, I did not make use of synthetic division. I make use of evaluating function, the long process. The reason is, in synthetic division, you can only use it properly if the divisor is like x minus 1 or the divisor is x, positive, negative, for any value. But if it is not like this, then that will not be a proper way to do it. No? So that is why I make use of evaluating function. So x minus 1, so what we are going to do here is we are going to equate this by 0. And of course, applying addition property of equality in this, so we have x is equal to 1. And what we are going to do with this value of x, which is 1, we will replace x in the given polynomial function. So let's start with x cubed. So we have 1 to the power of 3. We will replace also x in our quadratic term. So we have negative 4 times 1 raised to the power of 2. Then we will replace x by negative 2 times 1. And we copy positive 5. Simplifying this, of course, we know that 1 raised to the power of 3 is, of course, 1. And 1 raised to the power of 2 is, of course, 1. And that is negative 4 times 1. And negative 2 times 1 is negative 2. And we just copy positive 5. Simplifying this further, of course, negative 4 times 1 is negative 4. So 1 plus 5 is, of course, 6. And negative 4 plus negative 2 is negative 6. And 6 minus 6 is, of course, 0. Oops, the value is 0, which is also the remainder. Therefore, we can say that x minus 1 is actually a factor of the given polynomial function. So I hope you can give a like to this video and kindly share this for others, for them also to learn just like what you did in this session. And please do not forget to subscribe to my channel, and please click that notification bell for you to be updated with my next tutorial. Thank you so much.